Hello everyone. In this video clip, I'm going to discuss this non-routine circular measure question with all of you. Now let's start. Susan wants to make a cap in the shape of a cone as shown in diagram 6.1, and the height of the cone is 24 cm. So let's just put in the information. Okay, so the height has to be 24 cm. Equals to 24. And let's find out what is the radius. Okay, so the radius for this cone will be 17.8 divided by 2. That will be 8.9. Okay, and then diagram 6.2 shows the net of the cone in the form of a sector of a circle with center O. Means if I cut the sector out and I fold it, I will form the cone. So the point O here will be the vertex, okay, the peak of this cone shape. Okay. All right, what other information do we have? Okay, so this net of the cone is drawn on the rectangular card, and we need to find the minimum value. That means we need to maximize the usage of this card. So if I cut out this sector that form this cone that fulfill all this measurement, what is the minimum value for my width and the length of this card? So that is the requirement of the question. So now let's look at this cone with the height and with the radius. If we spread this out, okay, look at the net, the slanting height will actually form the radius of the sector in diagram 6.2. Therefore, with this radius, okay, if I were to maximize the usage, that means the width here will be just nice. It will take the size of the radius of this sector as well. So the width here, W, should be the same size as the S. So our objective first is to find the S. How do we find the S? By looking at the cone. Okay, can you see that it is actually a right angled triangle? So we can use the Pythagoras theorem to find the value of S. So for part A, right, let's find the slanting length. That will be 24 squared plus 8.9 squared, and got to square root the sum of it. Using calculator, we will get 25.6, yeah, after we round off to the nearest, maybe 2 or 3 decimal places, we got 25.6. Okay, we got 5.9 something, so you round off, you got 25.6. So based on this, we know that the radius of this sector in diagram 6.2 will be 25.6. Okay, so the width should take up 25.6. However, the question says it has to be in the nearest integer. Okay, so we have to leave our answer in a whole number form. After that, what else do we know? We do know that the arc length of this sector in diagram 6.2, basically, if we fold it, okay, it will form the circumference of the base circle of the cone. So let's find out what is the circumference of the base of the cone. So in that case, circumference of the base, okay, will be 2 pi r. Right? So if we put the value in, 2 times, now pi is not given, so we use 22/7 times the r. The r here is 8.9. Right, so we have 55.94 cm. Okay, and we also know that this circumference of the base of the cone is also the arc length of this sector in diagram 6.2. So with that, okay, we have to apply the circular measure formula. With this angle theta here, let's find the theta first, the angle first. So according to S equals to R theta, whereby the S here is the arc length here, arc length S, okay, equals to R theta, and the arc length happens to be the circumference, which is 55.94 equals to R theta. The R here will be the radius of the sector. In this case, it is 25.6 theta. So let's find the theta. It will be in radian. So we have used the calculator. We have 2.185 radian. Okay. So with this, we need to find, we have found the width. We just need to find out the length. So we need to see how much more that we need to extend this side. Okay, let's call it the adjacent. Why? Because I'm going to form a right angle triangle here. Okay, if our sector stop at the green line here, green line S here, that means we have to take up this side, the adjacent side, and the A. So in this case, we can find the alpha here in radian. And then from there, for this alpha, we need to find what is the adjacent, okay, using the hypotenuse. So we have A, we have H, so we have to use cos, because according to SOHCAHTOA, okay, we need to involve the adjacent side, the hypotenuse. This is actually the hypotenuse. This is the adjacent for this right angle triangle. Okay, so with that, let's find out what is the alpha first, right? So alpha equals to 3.142. That is the value of pi minus the theta radian, 2.185. So using the calculator, alpha in radian is 0.957 radian. Okay, so we have to change this into degrees. Otherwise, use your calculator, set the mode, the angle mode in the calculator to radian. So we do not need to change the 0.957. If you want to change the degree, you just need to take 0.957 times 180 degree over the pi value. Then you'll get the alpha in degree form. But in this case, we just set the degree mode. Yeah, set the mode, set the calculator in the radian mode. Okay, set calculator in the radian mode. All right, so that we do not need to change to degree. Okay, now so in this case, we use the cos, so cos alpha, which is 0.957 radian. This is radian, yeah? Equivalent to the adjacent over the hypotenuse. Hypotenuse in this case is equal value with our radius of this sector in diagram 6.2, which is 25.6. So over 25.6. All right, so rearrange so that we can find our A. So the A value will be 14.75 cm. All right, so with that, we can find the length. The length will be 14.75 plus 25.6. Yeah, so with this S here plus the A here, they will make up our length. So just add these two together, we have 40.35. we need to find, therefore, answer the question, the minimum W, which we need to round off to the nearest integer. So the W over here is 25.6. So we round it off to the nearest integer, it will be 26 cm. And the length, minimum length in integer will be 41 cm. So we just found the answer for part A. Okay, so you need to understand the net of the cone. Okay, when we spread it out, okay, since the slanting length is fixed, it's not variable. All these are fixed, it's a constant value. So we just put in. Okay, so you do not need to form the equation in one variable to find the minimum value, because all the values, the measurement here are constant. So we have found A. Now B, we need to find the area of the cut unused. So the unused part will be here, this part. These are the unused part. These are the unused part. So we need to find this. So how do we find the unused part? So that will be area of unused part. It will be area of the rectangle minus area of the sector. So area of the rectangle will be 26 times 41, and then minus area of the sector according to the formula in the circular measure, half r squared theta. Okay, and the theta will be 2.185. Our r here is 25.6. Okay, just plug everything into calculator. So we get the answer 350.02 cm squared. That's it for this question. So this is a bit, it's a non-routine question whereby we need to apply the knowledge in circular measure as well as the basic knowledge of the geometrical shape and its net, the net of the geometrical shape that we have learned before. Okay, so I hope this one will help you. I'll see you in the next video, please.